Welcome to Unit 1 in Basic Soil Science. In this unit of instruction today, we're going to be talking about soil composition. What are the soil composed of, the basic phases or components, and how do these interrelate to each other in determining the overall properties of that soil. The first thing I think we should do is to get an agreement on a general working definition for the soil. What is it that we're talking about in this class, and what is it that we're not talking about in this class? To give you an example of that, what we're not talking about is artificial planting mediums, such as would be used in a greenhouse or horticultural environment. There we're taking, in some cases, man-made materials, in other cases, displaced components of the soil, and we're mixing them together to form a planting medium. That is not the type of soil that we'll be referring to in this class. My definition of the soil is that it's a natural medium for plant growth, meaning that it's a product of the environment. And it's composed of both the organic fraction and the mineral fraction. So if we're looking at the solid components of the soil, we're looking at these two major components, the organic fraction and the mineral fraction. Does, however, that definition include the entire soil? I want you to think about that for just a few seconds. Is the organic and the mineral fraction the only components of the soil which are important to us? Well, after having thought about this for a few seconds, I hope that you can see that we're only describing in the organic phase and the inorganic phase, or the mineral fraction, the solid component of the soil. And obviously that there are other components that are important to us there also. What about the pore spaces that exist in the soil? The pore spaces meaning the void areas that exist between those solid particles, both mineral and organic. Well, I think it's understandable that this mineral fraction, the sand, the silt, the clay size separates, are forming the framework of this soil. But then we have a number of pore spaces, some of them very large, which we would refer to as macropores, and then some of them much smaller, which we would refer to as micropores, that exist between these solid mineral particles. The organic fraction really kind of forms a coating, if you will. The finely divided humus portion of the organic fraction forms this coating around the mineral particles and becomes an overall part of that soil's solid volume. So this pore space that exists between the soils then can be occupied by either the gases in the soil or the soil air, or those pore spaces can be occupied by water. And I think we need to think of the water in the soil as not being just that water, but obviously once it enters the soil, it becomes mixed with other solubilized types of materials in the soil, and therefore I refer to this soil water as a soil solution, because it is important for us to realize that that water in the soil does contain many dissolved particles, which for now we'll just refer to as being ions, being charged particles that are solubilized in that water. Well, so now that we know the four major components of the soil, we've got mineral matter, we've got organic matter, we have the pore spaces, and they're occupied by the other two major components, the soil water or soil solution, which I prefer to call it that, and then the soil atmosphere, the gases which exist in the soil, or soil air. If we were to look at the percentage of these, in other words, if we take the so-called average mineral soil, what percentage of each of these components, or does each of these components make up in an average mineral soil? I would refer you to the graphic at this point in time. And as we look at that, what we'll see is that the soil is composed of about 50% solids, meaning mineral and organic material, and about 50% pore space. Now, obviously, it's important that we maintain this pore space in the soils, because if you were to compress that soil or compact it, which is a non-desirable characteristic from a standpoint of productivity, we are going to be squeezing out some of this pore space. And it is important for us to maintain that pore space relationship in the soil. So if we take a look at each of these components and discuss each of these separately, we've touched upon the mineral component already, but what percentage of a soil's volume, not weight now, but what percentage of a soil's volume is occupied by mineral particles? Well, in an average mineral soil, this is going to be somewhere in the neighborhood of about 45%. So if we say 45% of the total soil volume is occupied by mineral particles, the organic material fraction there represents about 5%. Now remember, we're using some average numbers here. And as we'll look at just a little bit later in the class, we'll see that those numbers do vary quite a bit dependent upon the size of the mineral particles or the textural classification of the soil. And if we took a soil that was at approximately field capacity, which we'll define that roughly as the amount of water that the soil can hold against the gravitational pull, we would see that that pore space would also be occupied by about 50% of it would be occupied by the soil solution or soil water, and the other 50% would be by the soil atmosphere. So we've got 50% solids, we've got 50% pore space, and then we further subdivide the pore space into 25% soil solution, 50% soil solution and 50% soil atmosphere. So we go back to the totals again here. We've got 25% soil solution, we've got 25% soil atmosphere, approximately 45% the mineral component of the soil, and 5% organic material. Now we've just finished summarizing what an average mineral soil would look like, with the percentage of volume occupied by mineral matter, organic matter, soil atmosphere, and soil water. That is not going to be the case for every soil. That's what we call this a typical soil or an average soil. Soils are quite variable, but they're going to stay within certain parameters in terms of the percentage of their volume occupied by each of these four major components. Now that mineral component is going to consist of the sand, the silt, and the clay-sized particles. These are often referred to as soil separates, and they're defined by the effective diameters of their particles. Generally speaking, sand is considered to be from 0.05 millimeters up through 2.0. The silt would be from 0.05 down to 0.002, and then the clay-sized particles would be anything with an effective diameter of less than 0.002 millimeters. Now those are very, very small particles. One might ask the question, what about the other mineral particles in the soil, those that are larger than sand? And yes, indeed, many soils do contain gravel-sized particles, cobbles, and or even stones. They are included within this mineral fraction, but interestingly enough, unless they're preventing or presenting some type of a barrier to what we're wanting to use that soil for, are actually not as important in the physical and chemical properties of that soil as are the clay, silt, and or sand-sized particles. So for now, we're going to leave the mineral fraction as about 45% of the soil's volume. Now obviously on a dry weight basis, if we were to look at the weight of the soil and what percentage of it is occupied by these mineral particles, it would be much more than 45 to 50%. It would probably be in excess of 90% of the total weight of the soil material. So it's important that we do analyze the soil and begin to think about it on a volume relation basis. And that is indeed what the overhead or the graphic is illustrating, is percent of soil's volume occupied by mineral matter, not the weight occupied by mineral matter.